Okay, so look at this problem. In a battlefield of ancient times, a soldier with a catapult stationed at the top of a cliff. Here is the catapult, and there is a cliff, totally vertical cliff, and here are the enemy camps. And the person has to launch this catapult with a velocity u, where u is equal to given as 40 meter per second at an angle 60 degree above horizontal. If the air resistance reduces speed of the stone at a rate k 0.1 meter per second per meter, that means we can write that minus dv dr is equal to k. So that is this implies that minus dv equal to k times dr, or suppose the velocity at a certain moment is this v, it makes an angle phi with horizontal. That means somewhere there, right? Somewhere there, velocity v, and it makes an angle phi with horizontal. So what we can do is that multiply this minus dv cos phi is equal to k times dr cos phi. Now you know dr cos phi, see that is dr and phi. So dr cos phi is dx, dr sin phi is dy, though that is not required, and dv cos phi is dvx. So minus d velocity x component, so minus dvx is equal to k times dx. So now we can integrate it. So minus dvx integrate for, at start you had u cos 60, and see that is the thing, while it goes through this distance d, then the velocity x component becomes 0. So at this point vx is equal to 0. So from then on the catapult moves vertically downwards. So therefore, so limits of integration will be u cos 60 to 0, and this is minus k. If you integrate this, so it will be from 0 to d. D is the required distance. So therefore we can write u cos 60 is equal to k times d. So therefore d is equal to u cos 60 by k.